All right. Good afternoon, everybody. I'm Dr. Jatinder Bali, and I thank the the All India Ophthalmology Society for giving me this opportunity to talk to you about artificial intelligence and scientific reporting, the techniques used, the clinical informatics, data management, and everything that is now left behind in this course. Now, I am the chairman of the DOS subcommittee on clinical informatics, information technology, and practice automation. I was formerly heading the information technology wing of a thousand-bedded hospital in the national capital, and I happen to have written a book on biostatistics and research methods. I have no financial disclosures to make in this presentation. Now, the first thing that comes to mind is that what exactly is artificial intelligence? Very simply put, it is the ability of whenever a machine or a computer is able to accomplish the tasks which required human intelligence, that is artificial intelligence. We're living in the era of driverless cars and Siri and Cortana and Google Assistant, or when you say that whoever bought this also bought this. So that is a suggestion that is being given. So that is all. Those are all examples of artificial intelligence. What are the different types of artificial intelligence? Let us focus on these three at the bottom here: artificial narrow intelligence, general intelligence, and super intelligence. Now, narrow intelligence simply means that if you teach the machine to play chess, it improves itself continuously in playing chess. But if it is able to transfer the techniques that it has learned in chess and starts improving, say, in economics or in solving ophthalmology problems, that is artificial general intelligence. That is transfer learning is there. So we are currently in this paradigm right now. But using ImageNet, we have come into artificial general intelligence because we are transferring some knowledge. Artificial super intelligence is at some future time when the machines will be able to pick up information from their surroundings and recursively improve themselves, and there will come a time when human beings are not the most intelligent people on earth, and that point is called singularity. And therefore we want everything to be done ethically, and because there would be these, we were talking about that black box approach. I'll just come to it. So we need to ensure that all the rules that we tell the machine are actually ethically correct. Now, when you look at narrow artificial intelligence, one thing, of course, is robotics, the driverless cars. Then we have machine learning, which could be supervised, where you have, training set. The training set teaches the machine, and then it uses it on a test set and then validates it into other areas. The other is unsupervised learning. Now, in supervised learning, first it is extracting the features, and then it is applying those features for classifying. In unsupervised learning, what it is doing is it is extracting the features as well as applying the classification at the same time. And then, of course, is machine perception, which could be, text to speech or speech to text or image recognition, and what machines can see. Now, why are we talking about artificial intelligence in healthcare today? You see, in the past, it was very expensive to store the data, to store large, humongous amounts of data. Now, memory systems have become cheaper, so we've started storing more and more data, whether it is electronic records or clinical data or electrodiagnosis. Now, every time a patient comes to you, since we have data, we are analyzing it, we're creating algorithms. Those algorithms are further helping people who are not experts in that domain. And that is what artificial intelligence is. When the patient used to come to the doctor, he used to, the interaction used to be a transaction, and we used to write some sort of a prescription. Then subsequently we had these electronic systems where we started, keying in those names and numbers, and we would store it either in the form of a prescription or a case sheet, or you could store it on the same computer on which you had fed it, or it would go through wires onto another computer, which could be the cloud, or could be the something called the server, where it would be stored in the form of, a master chart or in the form of files. So that is the file transport, FTP servers. Now, this is on this the on this server, limited algorithms which you have already developed are now acting and telling you that whoever bought this also bought that. But suppose you want to develop new algorithms, what do? You cannot do it on live servers. You take this data out and you put it into another computer, which you call the data warehouse. You clean it, integrate it, and then you run data mining tools, or you run different type of tools and find some patterns, and based on that you derive new algorithms. Now, what are those algorithms? Now, in healthcare, the simplest ones that we can talk of are some sort of regression analysis, wherein y is or the disease or the is the dependent variable, and x z, which could be age, could be gender, could be any of those variables. So these are the independent variables. So what we are trying to do in regression is we are trying to find one equation which explains all disease using the predictor variables or the independent variables. And there are different types of regressions that were described depending on whether it was continuous variable, or it was yes no type of nominal variable, or it was a categorical variable, right? So you could have probit regression or linear regression. The next type of commonly used method is what we call support vector machine. In support vector machine, what it is doing is it is just trying to find out a line. It is trying to draw a line which is going to separate the cases from the controls, or the yes from the no's, in such a manner that the gap between these two groups is the largest. So this is the negative or positive hyperplane, and this gap remains the largest. So, and then you start using this red line for classifying ROP, no ROP, referable, not referable. Then of course then we talked of finding out about clustering. That's nearest neighbor analysis. So you get a large minus z value that shows there are clusters, that it is all your data or all these points are arranged in clusters. But you get a large z value, the machine says, okay, all this data is dispersed out, and that is how it starts analyzing. And multiple techniques can be used in multiple layers. Then of course is decision trees. In decision trees, what it is doing is it is just creating those it is creating a flowchart, and then on those flowcharts, what it is doing is uh, using those flowcharts, it comes to a decision. When you use multiple decision trees, that's a random forest. For example, you want to see whether it is a hemorrhage. So if it's a red pixel, don't look at a single pixel, look at a number of pixels in that area. And if large majority of the pixels are saying that it is this, then the majority wins. A democratic majority is there. We talked of neural networks, and then neural network, what is happening is all the predictors are acting as an input, and the disease is acting as an output. And in between are multiple layers which are capable of tuning and fine tuning. So I can actually put different mathematical values in these hidden layers to ensure that I get the output. And these are fantastic ones like AlexNet, VGGNet, and GoogleNet, or Caffe and TensorFlow. And then of course the naive Bayes, which acts like our testing mechanisms, where we used to do we used to look at what was the prior probability of disease, and then find out the likelihood, and then come to an eventual this thing that this is what is most likely the outcome. So this is when you are trying to teach your machines supervised learning. So you divide the data into two halves, train it using one half, and then test it using the other half. And that is how we're using the classical machine learning methods. Now, so far as reporting in science is concerned, we are already using it for identifying new peer reviewers, fighting plagiarism, sample size, bad reporting, even checking out data fabrication. But neural networks were finding it very difficult to actually report science, because it's a very long string of data, and these work on multiplication of matrices. Now there is a very interesting theory which has come up, where they say that look at how the vector rotates, and this rotational unit of memory has been used to run the complete paper into the machine, and number of papers, and they will give you 3 or 4 lines, sum the entire paper, the results of the entire paper in three or four sentences. So this is IBM Watson Health is an algorithm which was named after Thomas Watson, and it has a natural language classifier service which is helping us actually, uh, which is allowing us to uh, using this we can do the reportings. And after this I will come quickly to we've already covered Tele Ophthalmology. We've covered artificial intelligence in ROP. The largest one, of course, is. Are we out of time?
We
We
have
have 5 minutes.
2 minutes, sir.
Okay, I'll just so basically what we are looking at is Dr. Manisha has thankfully covered artificial intelligence in ROP, and the only other thing that we need to talk about is teleophthalmology. Now, teleophthalmology. Whenever we talk of teleophthalmology and ROP, the first thing that comes to mind is the Sundrop, is the Stanford University network for diagnosis of retinopathy of prematurity, and its Indian variant, the Karnataka Internet Assisted Diagnosis of ROP. Now, what is important to understand in ROP is that all these were feature extraction systems. First, they extract the features, and then classification was done on based on them. We had things like ROP tool, retinal image, multi-slice analysis, vessel map, and CAIAR. And of course, we've already talked of the support vector machine, which says ROP is there or ROP is not there, and refer it. The convolutional neural networks, that is the IROP system, and the IROP's DL based continuous severity score, which helps us actually grade the severity of the severity using a slightly different technique than what is really available. And so far as teleophthalmology is concerned, telemedicine policy was given by the government of India in March of 2020, and it does allow us extensive outreach, avoids unnecessary referrals, saves cost, and provides professional opinion at a very small cost, and provides protection against infection. However, there are problems. We have connectivity problems. We're trying to sending expensive equipment in these large buses to rural areas, and the data, and trying to do real time video conferencing, which given our limited bandwidth can be a problem sometimes. In addition, we cannot send systems which require a lot of which are energy guzzling systems. So we need systems which are more like mobile platforms and use lower power settings. And we're trying to push for you know or what we're trying to do is trying to push for mobile teleophthalmology units. This is something that one South Indian institution. This is uh, a flow chart that they had made, and this is what they are using. These are just suggestions. There are no guidelines in teleophthalmology that have been issued. And the main problem, of course, is patients are not very happy with it, and there is a very high initial cost of investment, and you need trained staff. Of course, we need to look at the cost of the hardware and the software also. And so far as artificial intelligence is concerned, we've already covered the fact that there are medical legal issues and regulatory issues. You see, the doctor-patient relationship, the patient comes to the doctor, and this is acting only as a decision support tool. Minus IDXDR, there is no other direct relationship that is there with the patient. And whenever any suits are pressed, they will be pressed against the practitioner. So we have to ensure that we don't get caught up in a tussle where we are not able to explain why a particular decision is being taken. At some stage it is going to become like that, where we won't be able to explain how we got to a particular decision in terms of say the diagnostic abilities of these machines. And that is the reason why we need to look at the privacy concerns, the data anonymization issues, and also the fact that you see these algorithms are being developed on data which is not being generated in the place where it is going to be utilized. So you will need some sort of bridging studies, and all those are issues uh, which need to be evaluated and accepted. So I thank. With that, I come to the end of my presentation, and I thank I thank the participants.